last class we studied SAQs from ray optics. So now we will study the SAQs from ray optics as well as electric charges and field chapter we have studied. So today we'll discuss some questions from potential and capacitance and also moving charges. Okay. So first, from potential and capacitor chapter, the question is derive an expression for principle of parallel plate capacitor. Derive an expression for principle of parallel plate capacitor. So we need to find equation or the expression for capacitance of the parallel plate capacitor or principle of also, or you can capacitance also you can call. Capacitance of parallel plate capacitor. So in this one we know that parallel plate capacitor. So we have two parallel plate capacitors which are separated by a certain distance. Let us assume that it is a D, and in between them the medium is present between them is air, and this is side is we have given positive charge, and this side we have given as negative charge, and this side charge density is plus sigma, this side charge density minus sigma, and in between them we have air medium is there. Okay, so here we consider a two plates of each area A and are kept at D apart, D distance apart. So we know that it is a positive charged plate, this is a negative charged plate. So here this will produce some electric field and this will also produce an electric field, and we know positive charge के वजह जो electric field होगा away, negative charge के वजह electric field होगा towards to the charge, away from the charge for the positive. So we consider here there is a one point I have taken here. Due to this positive charge, electric field is this side, that is E plus. And due to this negative charge, because the positive charge to away from positive charge, so that's the reason I took here. Positive charge here, away means here. And negative charge. Because of negative charge, electric field is towards the positive negative charge, towards the negative charge. That means यहाँ पे पूरा negative charge है plate के ऊपर, इसके वजह से यहाँ पे जो electric field जो होगा towards the plate रहेगा. मतलब ये जो point में towards the plate मतलब इस तरफ, वो भी right hand तरफ आ रहा है, ये भी E plus इधर ही आ रहा है. That means both are acting on same direction. Both are acting at same direction. So net electric field at any point inside, if you want to take, because we know it is an a plates, conducting plates. electric field in front of them, it is uniform. So everywhere you take, it will be same, will get. So the net electric field is sum of these two electric field produced by positive and negative charge. So if I say electric field due to plus sigma is E plus, that is sigma by 2 epsilon naught right side as from the diagram. And electric field due to minus sigma is E minus, that is sigma by 2 epsilon naught. ये भी राइट साइड है, ठीक है ना। अब किसी का ऐसे डाउट आता है, सर यहाँ पे प्लस है इसलिए यहाँ पे प्लस लिख दिया, यहाँ पे माइनस है यहाँ पे माइनस नहीं लिखे आप। तो इलेक्ट्रिक फील्ड इज इन वेक्टर क्वांटिटी, नेगेटिव पॉजिटिव के वजह से डायरेक्शन चेंज होता रहेगा, बट उसको मैग्नीट्यूड तो लिखना है। तो इसलिए हम नेगेटिव के वजह से इलेक्ट्रिक फील्ड इधर लिया ई माइनस के लिए। सपोज ये भी प्लस है तो द डायरेक्शन इधर आते, करेक्ट। सो इसलिए सिग्मा बाय 2 एप्सिलॉन नॉट, सिग्मा बाय 2 एप्सिलॉन नॉट ड्यू टू द नेगेटिव एंड पॉजिटिव प्लेट, करेक्ट। चलो नेट इलेक्ट्रिक फील्ड निकालेंगे अभी। जो नेट इलेक्ट्रिक फील्ड जो है, नेट इलेक्ट्रिक फील्ड एट सेम पॉइंट जहां पे हम इलेक्ट्रिक फील्ड ड्यू टू नेगेटिव एंड पॉजिटिव चार्ज निकाल दिया, सेम पॉइंट। सो ई नेट विल बी सिंपल सिग्मा बाय 2 एप्सिलॉन नॉट प्लस सिग्मा बाय 2 एप्सिलॉन नॉट, दोनों एक ही डायरेक्शन में है, सबको ऐड कर रहा है मैं। So finally it will get sigma by epsilon naught towards right. Yes or no? So now we have got electric field between them. But one more thing we know, ये दोनों को बीच में, दो प्लेट के बीच में एक डिस्टेंस दी है और दोनों के बीच में इलेक्ट्रिक फील्ड मालूम है हमको। So इलेक्ट्रिक फील्ड और डिस्टेंस बिटवीन द टू पॉइंट्स भी पता है, मतलब टू प्लेट्स और टू पॉइंट्स। सो पोटेंशियल डिफरेंस भी निकाल सकते हैं बाय यूजिंग इलेक्ट्रिक फील्ड एंड पोटेंशियल डिफरेंस का रिलेशन यूज करके। सो पहले पोटेंशियल डिफरेंस निकालेंगे। सो वी नो पोटेंशियल डिफरेंस बिटवीन प्लेट्स इज डेल्टा वी, and that delta V can be written as per that we know E into D. Only magnitude we are taking because already direction we have taken in that. So E into D. So we know E is sigma by epsilon naught into D. But in this one, sigma is surface charge density. Surface charge density means charge per unit area, charge per unit area. So that means from here I can write, but sigma is Q by A, charge per unit area, Q by A, where A is a plate of each area, area of each plate, and Q is a charge on each plate. So from this sigma is equal to Q by epsilon naught means यहाँ पे sigma is equal to Q by epsilon naught रखेंगे, yes. So delta V is equal to Q by A into epsilon naught into D, yes or no? But as a definition of capacitance of any conductor, so capacitance we can write here, but capacitance C is equal to Q upon delta V, charge upon potential difference. So we know the potential difference here, yes. We know charge here, yes. So can I divide this one? Q upon delta V, delta V take this side and everything will be taken this side. So what happened you see from that? So this A epsilon naught came here and D comes in the denominator, and this will be going to be Q upon delta V, Q upon delta V. But at the definition of Q by delta V, we know Q by delta V is C. So finally we can write capacitance. C is equal to epsilon naught A upon D. Epsilon naught A upon D is a final expression for the capacitance of parallel plate capacitor. Of parallel plate capacitor. Is the derivation clear, everybody, students? Any doubts? No doubt, right? Okay. Yeah. Next. So next we'll go to the next chapter, that is moving charges. Moving charges. So from that chapter, the moving charges, the question is state and explain the Biot and Savart law. State and explain Biot and Savart law. What is Biot and Savart law means? In moving charges, basically, moving charges, when charge is at rest, it will create electric field. When charge is in uniform motion, it creates electric and magnetic field. And when it is in accelerated motion, it will create both electric, magnetic as well as radiate energy. But when a moving charge produces magnetic field or a current carrying, moving charge means it will produce current. When a current carrying wire produces magnetic field, how we can find a magnetic field due to current carrying a wire? Current carrying a wire. So to find the magnetic field due to any type of current carrying wire, we will use this law provided by Biot and Savart. Okay. So what is statement and that expression we'll see now. So according to this, so we imagine any something like any zigzag conductor first carrying current. So he has taken as some zigzag conductor like this, in which current is like this is going. Any shape conductor. So what he did, so he took some small elementary length. Elementary length. Small elementary length of length DL. Or from this current I is passing, and from this there is a point P at which मुझे magnetic field निकालना है. तो क्या करना है, ये जो पॉइंट्स डीएल एलिमेंट से एक पोजीशन वेक्टर लिया मैं, वो पोजीशन वेक्टर है आर, और जो पोजीशन वेक्टर विद द डीएल वेक्टर डीएल इनटू आई ऐसे है. सो पोजीशन वेक्टर इधर है. सो दोनों के बीच में जो एंगल है थीटा, दोनों के बीच में एंगल थीटा. Clear now? Okay. So this DL, we can write here I into DL. The current I which is passing through a wire, but in which a small element we have taken, that is DL. So that is I into DL. We will take a small current element. Current element. And R is यहाँ पे O लिया. So OP, position vector. Position vector. ठीक है? So as from this Biot and Savart law, means magnetic field due to any current carrying due to a small element DL, small element DL at a given point P at a distance of R is proportional to current element, directly proportional to current element, and inversely proportional to of the distance, inversely proportional to square of distance. और बीच में एक एंगल थीटा भी है तो उसको प्रोपोर्शनलिटी साइन थीटा आ जाता है. So as per this statement we can write the magnetic field at P due to current element DL is dB. It is directly proportional to current element and inversely proportional to square of distance. Magnetic field at a P is due to current element DL is directly proportional to current element and inversely proportional to distance. So current element means ideal. Distance means R. So directly we can write the magnitude of vector, that is dB, is equal to proportional to ideal as per the statement, directly proportional ideal and inversely proportional to R square. So if you cancel the proportionality, we will get something like constant, that is mu naught by 4 pi ideal sin theta by R square. A complete magnetic field is required. So we need to do integration. That is mu naught I 4 pi integration of dl sin theta by R square. So this is what we called Biot and Savart law. Biot and Savart. Clear now? Student, is it clear that question? We'll see one more question from the same chapter. The question is, state and explain the Ampere circuital law. State and explain Ampere circuital law. What is Ampere circuital law means? Biot-Savart law, actually it can be used to find the magnetic field due to any kind of current carrying wire. Correct? But this Biot-Savart law is a difficult, very integration methods or some calculation part is very high to find a magnetic field due to different current carrying wires. But if we have a symmetric current distribution bodies, a symmetric current carrying bodies are there, you can find very easily the magnetic field due to that current carrying wires or current carrying distribution bodies. Very easily we can find, like how the Gauss law will be used in electrostatics to find electric field due to symmetric charge distribution. In this way, the Ampere's law also used to find an magnetic field due to a uniform or symmetric distribution of current, a uniform distribution flow of electric current. So for that, this law can be useful. So what is that law means? This law is saying that statement. The line integral of the line integral of any closed the line integral of magnetic field into dl, b dot dl, or any closed path is equal to mu naught times of total current enclosed in closed path. Closed. So from this, so statement, the expression wise you want to write like this: integral, closed integral of b dot dl. This will be equal to mu naught times of I enclosed by closed surface. correct? So if you want to say, for a simple diagram, if I imagine this, you see, we have a current which is flowing outward. This is symbol is outward. Perpendicular to dot means perpendicular to outward. ऐसा बाहर आ रहे करंट, और ये I1 करंट ले लो. ये कौन सा करंट है? I1. और यहाँ पे दूसरा करंट है, ये एक करंट है बाहर आ रहा है आउटवर्ड, सो इसको करंट जो नाम दिया I1. दूसरा करंट है यहां से इनवर्ड है, ये इनटू, इनटू मतलब अंदर जा रहा है, अंदर ऐसे जा रहा है, ये I2, ठीक है. और यहाँ पे एक I3 है, ये भी अंदर जा रहा है. सो मेरे पास टोटल 3 करंट कैरिंग वायर्स हैं. मैं ऐसा प्लेस के एक तो करंट अंदर जा रहा है, दूसरा बाहर आ रहा है, तीसरा वाला भी अंदर जा रहा है. सो मैं ये जो एम्पियर लॉ लगा के कैसे निकालना है मैग्नेटिक फील्ड देखे, और हाउ आई कैन अप्लाई एम्पियर्स लूप लॉ और सर्किटल लॉ. सो आई एम टेकिंग वन इमेजिनरी एक क्लोज सरफेस ऐसे लिया मैं, क्लोज सरफेस वाला, ये सरफेस क्लोज्ड वाला, ये क्लोज्ड में अंदर में आप उस जो सॉरी क्लोज लाइन लिया, क्लोज लाइन और लूप, दिस इज कॉल्ड क्लोज लूप, क्लोज्ड पाथ, और loop we call, it is also called ampere loop. एम्पियर लूप. ये एम्पियर लूप के अंदर एक I1 और I2 है, दो करंट है, बट एम्पियर लूप के बाहर I3 है. टोटल करंट 3 are there, but in that 2 are inside, one is outside of the ampere loop which we have imagined. So from the statement of the law, what I can write from the statement of the law? Integration of B dot dl is equal to mu naught times of I closed or enclosed, right? I enclosed. So enclosed मतलब उसके अंदर कितना है, लूप के अंदर कितना करंट है, लूप के अंदर तो I1 I2 है, I3 तो बाहर है. तो हम ऐसा इंक्लूड करना है यहाँ पे, जितना करंट एनक्लोज्ड है बाहर वाला नहीं लेना. तो इसलिए क्या लेना पड़ेगा, खाली I1 I2 लेना है, बट उसमें I1 भी, एक I1 बाहर आ रहा है, एक I2 अंदर जा रहा है. सो वन यू कंसिडर प्लस, अदर वन ऑटोमेटिकली माइनस. मैं आउटवर्ड को प्लस माने तो इनवर्ड क्या होगा, माइनस. तो इसमें ऐसे लिख सकते हैं हम, इंटीग्रेशन ऑफ बी डॉट डी एल इज इक्वल टू म्यू नॉट इंटू I1 पॉजिटिव लिया, सो I2 नेगेटिव हो जाएगा, और I3 नहीं लेना है क्योंकि वो आउटसाइड ऑफ द लूप, it's outside of the loop. Outside of the loop. Clear now? Is this question is clear, everybody? Any doubt? Is it over, students? Understood, everybody? Okay. So moving into next question. That is, one question came in the last paper. Derive an expression for dipole moment of revolving electron, revolving electron in an orbit. ठीक है, वो डिस्कस करेंगे. चलो, नेक्स्ट क्वेश्चन इज expression for dipole moment of revolving electron. Dipole moment of revolving electron. It's simple only. Dipole moment is magnetic dipole moment is current into area. Current into area. So any current carrying coil acts as a dipole. Any current carrying coil means closed path. So any closed path or any loop, any current carrying loop or coil act as a dipole, magnetic dipole. और उसमें जो लूप में एक तरफ नॉर्थ पोल जैसे और दूसरा तरफ साउथ पोल जैसे बिहेव करते, तो इसलिए इसको जो डाइपोल लूप को क्या नाम दिया, डाइपोल. तो डाइपोल है तो इसके पास कंपलसरी डाइपोल मोमेंट होना है. सो वैसे इलेक्ट्रॉन भी एक ऑर्बिट में मूव कर रहा है अराउंड द न्यूक्लियस, अराउंड द न्यूक्लियस. सो मतलब एक ऑर्बिट में मूव कर रहा है. सो ऑर्बिट में मूव कर रहे हैं मतलब रोटेशनल करंट डेवलप कर रहे हैं. तो रोटेशनल करंट मतलब वैसे लूप वैसे डेवलप कर रहा है. सो इसलिए वो डाइपोल मोमेंट ऑफ रिवॉल्विंग इलेक्ट्रॉन क्या रहेगा. सिंपल, हम क्या निकालेंगे, पहले रिवॉल्विंग इलेक्ट्रॉन के वजह से करंट क्या रहेगा निकालेंगे. और वी नो द रिवॉल्विंग इलेक्ट्रॉन ऑर्बिट इज सर्कुलर. तो सर्कुलर का एरिया हमको मालूम है पाई आर स्क्वायर, वेयर आर इज द रेडियस ऑफ द ऑर्बिट. और एक करंट निकालने के बाद I into A करेंगे, दैट इज द डाइपोल मोमेंट ऑफ मैग्नेटिक डाइपोल. तो फर्स्ट डेफिनेशन ऑफ मैग्नेटिक डाइपोल इज magnetic dipole moment, that is M, that is I into A, current into area. तो हम पहले क्या करेंगे, इसे एक सर्कुलर ऑर्बिट इमेजिन करेंगे, इसमें एक इलेक्ट्रॉन चल रहा है, मूव कर रहा है. ठीक है ना. ऐसा यहाँ पे एक सेंटर है, वो न्यूक्लियस है, पॉजिटिव चार्ज. यहां से एक इलेक्ट्रॉन ऐसा v वेलोसिटी से चल रहा है और इसमें से जो रेडियस r है, ठीक है ना. इलेक्ट्रॉन इज रिवॉल्विंग इन ए पर्टिकुलर ऑर्बिट ऑफ रेडियस r with a velocity v. Okay, now we will see करंट क्या रहता. फर्स्ट, current produced by revolving electron. What is produced by revolving electron means revolve ऐसे कर रहा है ना, रोटेशनल करंट प्रोड्यूस कर रहा है. तो क्या रहे ना, करंट एज पर द डेफिनेशन ऑफ करंट वी कैन राइट चार्ज अपॉन टाइम. चार्ज अपॉन टाइम. चार्ज कितना यहाँ पे इलेक्ट्रॉन का चार्ज है ई। टाइम, टाइम क्या रहता, एक रेवोल्यूशन में कितना टाइम, वो टाइम पीरियड बोलते हैं। क्या बोलते हैं? टाइम पीरियड बोलते हैं, एक रेवोल्यूशन में टाइम पीरियड टी। बट इलेक्ट्रॉन घूम रहे सर्कुलर ऑर्बिट में वी वेलोसिटी से, आर रेडियस का ऑर्बिट है। तो एक सर्कल में कितना डिस्टेंस ट्रैवल करेगा? सरकमफ्रेंस ऑफ द सर्कल, सरकमफ्रेंस ऑफ द ऑर्बिट, दैट इज 2 पाई आर। कितना स्पीड से चल रहा है? v स्पीड से। तो मुझे एक रेवोल्यूशन में स्पीड पता है, डिस्टेंस भी मालूम है। सो कैन आई फाइंड टाइम पीरियड? दैट इज टाइम आई कैन राइट t can be written as distance, that is 2 pi r by speed v. So यहाँ पे सब्स्टिट्यूट करें तो I is equal to E upon t 2 pi r by v, v तो ऊपर आ जाएगा, करेक्ट। सो जो करंट मुझे आया EV by 2 pi r आ गया, EV by 2 pi r तो आ गया। सो मुझे क्या चाहिए? डाइपोल मोमेंट। डाइपोल मोमेंट एज पर द डेफिनेशन ऑफ डाइपोल मोमेंट क्या है? m is equal to I into a। सो एरिया मुझे मालूम है, सर्कुलर ऑर्बिट का एरिया पाई आर स्क्वायर, और डाइपोल मोमेंट आई इज इक्वल टू, सॉरी, एम इज इक्वल टू आई इंटू ए आई ई वी अपॉन 2 पाई आर इंटू पाई आर स्क्वायर, करेक्ट। सो यहाँ से आर, एक आर, पाई पाई कैंसिल हो जाएगा, जो बच रहा है आंसर यहाँ पे ई पाई इंटू ई वी बाई, पाई भी खत्म, पाई भी निकाल, हटा कैंसिल हो गया ना, तो यहाँ पे आर बच गया। सो ई वी आर बाई 2 एम, ई वी आर बाई 2, yes or no? This is dipole moment of revolving electron. थोड़ा से मैथमेटिकल इक्वेशन तो है, बट डिफिकल्ट तो नहीं है, थोड़ा से मैथमेटिकल इक्वेशन से इन्वॉल्व है, उतना ही पता होना चाहिए आपको। चार्ज बाय टाइम, टाइम कहाँ से निकल, 2 पावर बाय वी, उसके बाद आई इंटू ये मल्टीप्लाई कर रहे, खत्म। Is it clear, students? Today we discuss around 4 VS SAQs we discussed today, correct? So now you have any doubts, students, you can ask me regarding all these 4 questions. पूछ रहे हैं। Any doubts, students? Yeah, students, so almost we have covered LAQs and the SAQs, which are important one, very important one. We have covered SAQs and LAQs we covered. So tomorrow in the we'll say from the different chapter which are sorry, from the chapters only VSAQs will come. Okay. So some of the chapter we have like moving charges, magnetism, ray optics, semiconductors. From these three chapters, along with SAQs, there are VSAQs will also come. But there are 4 chapters are there, 4 or 5 chapters are there. In that exclusively VSAQs will come. So from which chapter VSAQs will come, and in the most important VSAQs is how many are there. So tomorrow I will explain about all that VSAQs from different chapters. Most of them, most of the question are easy only. You can able to read yourself also. All theoretical questions are there. So tomorrow I'll say what are the question you need to study from the chapters and VSAQs. Okay. So till now, whatever we covered, SAQs and long answer, you repeatedly this, you go and listen the class once and twice and write on the paper once and twice with seeing, or now once you can try for without seeing, and like that you practice the questions unless you be perfect. Because we have discussed very limited, because within a small less time, within the small duration of time, to cover entire thing is also not possible, and for your side also to study everything is also not possible. So we have covered in such a way that you can score a good marks by studying these limited questions. But you need to learn and practice everything what we have discussed here. Then we have taken only important, very important questions. And in that also you have searched or you have filtering for some more question. It's not good. Okay. So we have filtered and given to you some questions with answers. And again, from that you don't filter it. What we have discussed from LAQ and SAQs, every question you practice once and twice till you perfect. Practice it, every question. So definitely you will be good score only. But if you perfect all the questions, clear now? So tomorrow also I will say how to prepare the VSAQs, from which chapter you need to focus more. So tomorrow we'll see about the VSAQs. Clear, students? Yeah. So today's session we will end here. Tomorrow we'll continue.